Good morning, everyone. This is Gayathri. Welcomes you all to today's class, that is Polynomials Part 5. In previous session, you have learned that how to find a quadratic polynomial when the zeros are given, as well as the sum and product of zeros are given, then how to find a quadratic polynomial. In today's session, you are going to learn the relationship between the zeros and the coefficients of a cubic polynomial. So, the first one here is a cubic polynomial. You see here the standard form of a cubic polynomial, which is ax cubed plus bx square plus cx plus d. Number of zeros of any cubic polynomial is always 3. Let us take the zeros of the cubic polynomial, that is ax cubed plus bx square plus cx plus d are alpha, beta and gamma. Already I said that in cubic polynomial we have 3 zeros. So we'll assume those 3 zeros as alpha, beta and gamma. So coefficients of the polynomial. X cube coefficient is A, x square coefficient is B, x coefficient is C and constant is D. Now let us see that how to find the relationship between the zeros as well as the coefficient. The zeros are alpha, beta and gamma. The coefficients are A, B, C and D. Let us see one example. So before going to the example, you see, first let us see the formula. Sum of zeros of a cubic polynomial is, that is alpha plus beta plus gamma, which is equal to minus b by a. That is nothing but minus of x square coefficient by x cube coefficient. Now product of zeros. Product of zeros, that is sum of product of zeros, that is alpha beta, beta gamma and gamma alpha is equal to, the formula is C by A. From zeros it is alpha beta, beta gamma and gamma alpha, and from coefficients the formula is C by A, that is coefficient of x by coefficient of x cube. Now product of zeros, that is from zeros alpha, beta and gamma, that is equal to, from the coefficient it is minus d by a, that is minus of constant, d is nothing but it's a constant, minus of constant by coefficient of x cube. These are the formulas. Based on these formulae you will be finding the sum and the sum of product of zeros as well as product of zeros of the given cubic polynomial. So let us see one example. In this example, if you see here the polynomial which is given, cubic polynomial, which is 2x cubed plus minus 5x square minus 14x plus 8. Let us write first all the coefficients. X cube coefficient, that is a, which is equal to 2, x square coefficient, that is b, which is equal to minus 5, and x coefficient, which is c, that is equal to minus 14, and constant, that is d, which is equal to 8. Now sum of zeros, directly from the coefficients the formula is minus b by a, so that is equal to minus of minus 5 by 2, because b value is minus 5 and formula is minus b by a, so minus of minus 5 by 2, that is equal to 5 by 2. Now the product of sum of product of zeros, formula is c by a, that is equal to minus 14 by 2, that is equal to minus 7. Product of zeros is equal to minus d by a, that is equal to minus 8 by 2, that is equal to minus 4. The same thing will verify with the another. Let us see the another example, that is how to find the sum and product and sum of product of zeros of the given polynomial. Another example, x cube plus 4x square minus 5x minus 2. Again write all the coefficients. We are finding out only through the formula, that is through coefficients we are finding the values here. So sum of zeros through coefficients formula is minus b by a, that is minus 4 by 1, which is minus 4. Sum of product of zeros formula is C by A, that is minus 5 by 1 is equal to minus 5. Product of zeros is equal to minus D by A, that is equal to minus of minus 2 by 1, which is equal to 2. Next, so you see here one very important question, that is from your exercise 3.3. Very important, children. P of x is equal to x cube plus 3x square minus x minus 3. Then the question is here that verify that 1, minus 1 and minus 3 are the zeros of x cube plus 3x square minus x minus 3, and check the relationship between zeros and the coefficient. This sum is very important for your 4-mark question, and it is a definite question for your 4 marks in your board exam also. So let us see how to solve this sum. First, write all the zeros which are given in the question, that is 1, minus 1 and minus 3. So let us find whether these are the zeros of the polynomial or not. To check whether these are the polynomial or the zeros of this given polynomial or not, you have to substitute in place of x these zeros, and if you get the value of the polynomial is 0, then we can say that it is a zero of the polynomial. So first P of 1. So in place of x substitute 1, that is 1 cube plus 3 into 1 square minus 1 minus 3. 1 cube value is 1 and 1 square is also 1. So 3 into 1, that is 3. Next minus 1 minus 3. If you observe there in the third step, 2 plus 1 minus 1 and plus 3 minus 3. So both 1 and 3 both are cancelled with positive opposite signs. So its value is 0. So now P of 1 is equal to 0. So we can say that 1 is a 0 of P of x. Now let us find P of minus 1. That is equal to minus 1 whole cube plus 3 into minus 1 whole square minus of minus 1 minus 3. That is equal to minus 1 whole cube is minus 1, minus 1 whole square is plus 1. So 3 into 1 plus again minus of minus 1, it will become plus 1, and last term is minus 3. Then once again if you simplify, minus 1 plus 3 plus 1 minus 3. Again all you see plus 3 minus 3 and plus 1 minus 1, which is equal to 0. So value of P of x is equal to 0. So minus 1 is a 0 of P of x. Now let us verify with the third 0, that is P of minus 3. Minus 3 whole cube plus 3 into minus 3 whole square minus of minus 3 minus 3. That is equal to minus 3 whole cube value is minus 27. Minus 3 into minus 3 into minus 3, which is minus 27. Then 3 into minus 3 whole square, that is 3 into 3, 9. And minus into minus will become plus. So 3 into 9 plus. Next one is minus of minus 3. So it will become plus 3. And last term is minus 3. Then once again if you simplify that, minus 27 plus 27 plus 3 minus 3. Again all the terms are cancelled. So the value is 0. So P of minus 3 is equal to 0. So minus 3 is the 0 of P of x. So here we verified that 1, minus 1 and minus 3 are the zeros of the given polynomial, that is P of x. Now how to verify the zeros as well as the coefficients of the given polynomial? Let us take now. Already we have given the zeros as 1, minus 1 and minus 3. We'll assume those as 1 as alpha, that is alpha is equal to 1, beta is equal to minus 1 and gamma is equal to minus 3. Now sum of zeros formula is alpha plus beta plus gamma, that is equal to 1 plus minus 1 plus minus 3. That is equal to minus 3, because plus 1 minus 1 cancelled. So left over is minus 3. Same thing we'll verify through coefficients. Here A value is 1, B value is 3, C value is minus 1, X coefficient, so minus 1, and D value constant, which is minus 3. Sum of zeros formula is minus B by A, so which is equal to minus 3 by 1, that is equal to minus 3. So both are verified here, that is, this is minus 3 through zeros we got minus 3, and through the coefficients also we got minus 3. Now Second one, that is sum of product of zeros. So this one we'll find it first through zeros. The formula is alpha beta, beta gamma, and gamma alpha plus gamma alpha. So substitute all the values now. Alpha 1, beta minus 1. So alpha into beta, that means 1 into minus 1 plus beta gamma values minus 1 into minus 3 plus gamma alpha, that is minus 3 into minus 1, minus 3 into 1. So when you multiply 1 into minus 1, it is minus 1, and minus 1 into minus 3 will be plus 3, and minus 3 into 1 is minus 3. Plus 3 minus 3 are cancelled, so leftover is minus 1. Now we'll verify the same thing through coefficients. Through coefficients, sum of product of zeros formula is C by A, that is equal to minus 1 by 1, because C value is minus 1 and A is 1, so minus 1 by 1, which is equal to minus 1. So both are verified here. We got both the values as minus 1. Now the third one is product of zeros. First we'll verify product of zeros through zeros. Through zeros, the formula is alpha, beta, gamma. That is equal to alpha into beta into gamma. That is 1 into minus 1 into minus 3. So the product is minus 3 into minus 1, which is plus 3. Plus 3 into 1 again will become 3. Now same thing we'll verify through coefficients. Coefficients formula is minus d by a, that is equal to d value is minus 3, so minus d by a, that's why minus of minus 3 by 1, minus of minus 3 is plus 3, so 3 by 1, which is equal to 3. So it is verified. So in this way we can find out any cubic polynomial if for this cubic, there is a small difference between a quadratic and a cubic polynomial. Quadratic polynomial, directly the polynomial will be given. You have to factorize the polynomial by splitting the middle term. You have to find the zeros first. Then you have to verify the relation between the zeros and coefficients by taking those two zeros as alpha and beta. But whereas in cubic polynomial, directly the zeros will be given in the question. You have to check whether those are the zeros of the polynomial or not. First you have to check. Once after checking that whether those are zeros of the polynomial, then you will take those zeros as alpha, beta and gamma, and then you have to verify the relation between zeros and coefficients. So children, you have one more example in the same model. We have in the example, it is there. So that I will give you in the assignment. So you will complete only what you have learned today. The same thing you are going to do as assignment. So that will be practiced for you. So I think children, you understood that how to find the relationship between the zeros and coefficients of a cubic polynomial. So children, practice once again. This is very, very important. So that you will not forget. Understood children? So thank you very much. Thank you one and all.